In Chapter 3, we will talk about exponents. In 3.1, we will talk about exponent properties involving products. So first off, let's take a look at the definition of an exponent. An exponent represents a term called a base, which is multiplied by itself, called a power. For example, if we have negative 4 to the third power, negative 4 is our base, and the 3 is the exponent or the power. So this means a negative 4 is multiplied by itself 3 times. And if you multiply negative 4 times negative 4 times negative 4, this is going to be 16 times negative 4, which is going to be negative 64. And please feel free to use a calculator for this. Now, there's a difference between a negative 5 squared without a parentheses and a negative 5 squared with a parentheses. So first, let's do the case where we have a negative 5 squared with the parentheses. This is going to be negative 5 times negative 5, which will equal to positive 25. However, if we have a negative 5 squared without the parentheses, the difference is that the 2 only goes with the 5. It only goes with that base. The negative is separate. The negative doesn't get squared. So this means we have one negative and we have 5 times 5. So 5 times 5 is 25. We only have one negative. Therefore, this will give us a negative 25. So there is a difference between negative a to the m when there's no parentheses as opposed to when there is a parentheses. Okay, now let's take a look at the product rule for exponents, but to do that, let's first start with 2 cubed times 2 to the 5th. So 2 cubed is 2 times 2 times 2. We got the base 2 and you multiplied 3 times. We have 2 to the 5th, so we have the base 2 and that is multiplied 5 times. So if you were to rewrite this, we have the base 2 multiplied 1, 2, 3, 4, 5, 6, 7, 8 times, and this will be 2 to the 8th power. Let's take a look at 3 to the 4th times 3 cubed. So 3 to the 4th means we have the base 3 that's multiplied 4 times. Then we have times 3 cubed, so we have the base 3 multiplied 3 times. So overall, we're taking the base 3 and we're multiplying it 7 times. So this is going to be 3 to the 7th. So hopefully we can see a pattern that when you multiply the same base, you are adding the powers. So you're adding 3 plus 5 is 8, 4 plus 3 is 7. So if you have 3 to the m times 3 to the n, we take our base 3 and we simply add the powers m plus n. So the product rule for exponents says the exact same thing, that if you multiply the same base, we keep the base and we add the powers. Okay, add the exponents, keep the base. So here's an example. We have x cubed times x to the 5th. We keep the base and add the exponents, which will give us x to the 8th power. Here we keep the base, 6. We add the powers, 2 plus 7 plus 3. So 2 plus 7 is 9, plus 3 is 12, and this gives us 6 to the 12th. Now here's where it gets a little bit different. When you have something like 8x cubed times 3x to the 5th. So the best way to do this is to split this up into 2 different parentheses. One parenthesis contains the numbers, which are 8 times 3. The other parenthesis contains the x's, which are x cubed times x to the 5th. Okay, so 8 times 3 is 24. X cubed times x to the 5th. We keep the base, add the powers, and this will give you x to the 8th. So whenever you have multiple terms, it's always easiest to separate them out into different parentheses. For example, here we have a 12 and a 3, so that goes in one parenthesis. We got 12 times 3. Then we have the x's. We have x cubed times x to the 3rd, or sorry, x to the 7th times x to the 3rd. That goes in the second parenthesis. Then we have the y's. We have y to the 5th and y, so that goes in one parenthesis. And then finally we have a z to the 4th times a z to the 7th, and that goes in a separate parenthesis. So split up all the letters, split up the numbers into their own parentheses. Now we have 12 times 3, which is 36. X to the 7th times x to the 3rd, that's going to be x to the 10th. Y to the 5th, if there's no exponent, it's like an indivisible 1. This gives us y to the 6th. and then you have z to the 4th times z to the 7th. So if you add 4 plus 7, that's 11. This gives us z to the 11th. So that is the product rule for exponents. Now the power rule, let's say we have 2 cubed to the 2nd power. What this tells us is we have 2 cubed times 2 cubed. So our base, which is 2 cubed, it gets multiplied by itself 2 times. And by the product rule, we keep the base at the power, so that's 2 to the 6th. Same thing here. We have our base, which is 3 to the 4th, and that base gets multiplied by itself 3 times. So we have 3 to the 4th times 3 to the 4th times 3 to the 4th. So we keep the same base and we add the power. So 4 plus 4 plus 4 is 12, and that'll be 3 to the 12th. So in general, what we can see is 3 times 2 is 6, 4 times 3 is 12. We are multiplying the 2 powers. So when you have the same base but 2 powers, then those 2 powers get multiplied. That's what the power rule of exponents says. If you have the same base and you have 2 powers, you multiply the powers. And, of course, keep the base. So here's an example. 3 times 4 is x to the 12th. 2 times 8 is 4 to the 16th. Now, when you have multiple terms that are all being raised to the 4th power, then we split those up just like before. We have 3 to the 4th, and then we have x cubed to the 4th, and then we have 2 to the 4th. So every single term in the parentheses gets raised to the 4th power individually. 3 to the 4th is 3 multiplied 4 times, that's 81. Here we have 3 times 4, that's x to the 12th. And then here we have 2 to the 4th, which is 2 times 2 times 2 times 2, and that will give you 16. Same thing for letter D. We got negative 2 to the 4th. We have x squared to the 4th. We have y cubed to the 4th. And we have z to the 5th to the 4th. We have each of these terms raised to the 4th power. So negative 2/4 is negative 2 multiplied 4 times. That's going to be 16. 2 times 4 is x to the 8th. 3 times 4 is y to the 12th. And 5 times 4 is z to the 20th. In 3.2, we talk about exponent properties, but this time instead of using products, we're using quotients, which means we're dividing, whereas products are multiplying. So let's take a look. 2 to the 5th, it means we have 5 2's that are being multiplied together, divided by 2 times 2 times 2. Now, anytime we divide a 2 by 2, we can cross those out. So what we're left with is 2 times 2, which is 2 squared. Okay, the next one, we have 3 to the 6th. We have 1, 2, 3, 4, 5, 6 divided by 3 squared. So once again, we're going to cross those out. So what we have is we have 1, 2, 3, 4, 3, so 3 to the 4th. And the pattern, which hopefully you can see, is you keep the same base and you subtract the powers. 5 minus 3 is 2. 6 minus 2 is 4. So if you have 3 to the m over 3 to the m, it's always going to be the exponent of the numerator minus the exponent of the denominator. And that's what the quotient rule for exponents says. If you divide the same base, you keep the base and subtract the powers, but it's always the numerator minus the denominator. For example, let's say we're dividing x to the 9th, y to the 5th, divided by x cubed y. We split this up as x to the 9th divided by x cubed times y to the 5th divided by y to the 1st. If there is no exponent, it's always a 1. Now here, we keep the same base, but subtract the powers. So we have 9 minus 3. Same thing over here. We keep the same base, subtract the power. That's 5 minus 1. And this gives you x to the 6th and y to the 4th. Another one, so it's easiest to separate everything into like the numbers and then the x's and then the y's and then the z's. Okay, then we simplify this. So we got to think about 27 and 15. That's just a fraction which has to be reduced. We can divide these each by 3. 3 goes into 27 9 times, and 3 goes into 15 5 times. So the first fraction, we're just dividing these by 3. Now the second fraction, we have 18 minus 10. So this gives us x to the 8th. 18 minus 10 is 8. The next one we have y to the 9th over y. So we have 9 minus 1, which is going to be y to the 8th. And then we have 7 minus 6, which is going to be z to the 6th. Next rule, if we have a fraction raised to a power, then each of the individual terms get raised to the nth power, just like we saw in section 3.1. For example, if we have 2 divided by 3x squared y to the 4th power, then you take each individual term, so we take 2 to the 4th, then we take 3 to the 4th, then we take x squared to the 4th, and we take y to the 4th to the 4th. So take each of these terms, the 2, the 3, the x squared y to the 4th, and individually raise them all to the 4th power. Now 2 to the 4th is 2 multiplied by itself 4 times, that is 16. 3 to the 4th is 3 multiplied by itself 4 times, that is 81. Now with x squared to the 4th, you multiply 2 times 4, this gives you x to the 8th. 4 times 4 is y to the 16th. And that is it.